Hi, hello friends. Welcome to our channel AP Science Tech. నా పేరు సాయి కృష్ణ SA Physics. మన ఛానల్లో వచ్చేటువంటి ఎవ్రీ వీడియోని కూడా లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ కూడా చేస్తూ ఉండండి. So today is the most important topic of 10th class physics first lesson heat, the subtopic of thermal equilibrium. The subtopic of thermal equilibrium. Thermal equilibrium. What is thermal equilibrium? What is the thermal equilibrium? What is thermal equilibrium? So the simple definition of thermal equilibrium: two or more bodies having same degree of hotness or coldness. This is called as thermal equilibrium. Two or more bodies having same degree of hotness or coldness. Thermal equilibrium: two or more bodies having same degree of hotness or coldness. So when two bodies are placed in thermal contact, heat energy will be transferred from the hotter body to the colder body. When two bodies are placed in thermal contact, so when two bodies are placed in thermal contact, two bodies means two objects and two different objects to different temperatures. When two bodies are placed in thermal contact, two bodies means two different objects and different temperatures. Take a body of hotter body, and next one, this is colder body. This point of A, this point of B. This is a hotter body, this is a colder body. This body temperature 100 degrees centigrade, this body temperature 0 degree centigrade. Take two bodies, one body 100 degree centigrade, another body 0 degree centigrade. These two bodies are touching to each other. This means they are in thermal contact. So this is a thermal contact. So take two bodies, one of the hotter body and another colder body, this point of A, this point of B. So these two bodies are touching to each other. This means they are in thermal contact. So this is initial position. This is a final position. So this is initial position. After some time, this position of final position. What is that? What is going on? Actually, when two bodies are placed in thermal contact, heat energy will be transferred from the hotter body to the colder body. Colder body. A point of A, hotter body. Hotter body means highest temperature. And Point B, colder body, lowest temperature. Hotter body means highest temperature, cold body means lowest temperature. Definitely heat is a form of energy in transit that flows from a body edge, higher body temperature to a body edge, lower body temperature. So A to B. A means higher body, B means lower body. But heat is a form of energy in transit that flows from a body edge, higher body temperature to a body edge, lower body temperature. After sometimes this position of thermal contact and thermal equilibrium. So take a two bodies 100 degree centigrade and 0 degree centigrade. Two bodies are touching to each other, they are in thermal contact. This is a thermal contact. This is a hotter body, this is a colder body. So hotter body release heat. Hotter body release heat. Colder body gain or observe heat. Hotter body release heat. Colder body observe heat. So hotter body release heat, colder body observe heat. So when two bodies are placed in thermal contact, heat energy will be transferred from the hotter body to the colder body. This transfer of heat energy continues till both attain the same degree of hotness or coldness. This transfer of heat energy continues till both bodies attain the same degree of hotness or coldness. So at this stage we say that the bodies achieved thermal equilibrium. Thermal equilibrium denotes a state of a body where it neither receives and nor gives. So thermal equilibrium denotes a state of a body where it neither receive and nor gives out heat energy. So thermal equilibrium denotes a state of a body where it neither receive and nor gives out heat energy. So ఇవి ఎప్పుడైనా సరే థర్మల్ ఈక్విలిబ్రియం లో ఉన్నట్లయితే అవి అవుట్ ఆఫ్ నుంచి హీట్ ని గెయిన్ చేసుకోవడం గాని లేదా ఇన్సైడ్ నుంచి హీట్ ని రిలీజ్ చేయడం గాని జరగదు. సో ద నెట్ హీట్ ఈజ్ ట్రాన్స్ఫర్డ్ ఈజ్ zero. The net heat transfer is zero. The two bodies have same temperature. This is two bodies have same temperature. Two bodies have same temperature. This is a final position. So one second. So what is thermal equilibrium? Two or more bodies having same degree of hotness or coldness, this is called as thermal equilibrium. When two bodies are placed in thermal contact, heat energy will be transferred from the hotter body to the colder body. This heat energy heat energy will be transferred continuous till both bodies attain the same degree of hotness or coldness. This transfer of heat energy continues till both attain the same degree of hotness or coldness. At this stage we say that the both bodies have achieved thermal equilibrium. Actually Thermal equilibrium denotes a state of a body where it neither receives and nor gives out heat energy. So this is called as thermal equilibrium. This is the definition, one definition. This is the another definitions. This is the another definitions. Next topic. Explain thermal equilibrium with an activity. So first of all, what is thermal equilibrium? The simple definition of thermal equilibrium: two or more bodies having same degree of hotness or coldness. This is called as thermal equilibrium. Thermal equilibrium denotes a state of body where neither receive and nor gives out heat energy. Thermal equilibrium denotes a state of a body where it neither receive and nor gives out heat energy. So let's go in the topic. Explain thermal equilibrium with an activity. So take two cups and fill one of them with hot water and another with cold water. Take two cups and fill one of them with hot water and another with cold water. So this is cold water. So this is hot water and another with cold water and another with cold water. Take two cups and fill one of them with hot water and another with cold water. This is hot water. So this is cold water. Take a laboratory thermometer, not a clinical thermometer, only using the laboratory thermometer. Take a laboratory thermometer, put it in hot water. Take a laboratory thermometer, put it in hot water. Take a laboratory thermometer, put it in hot water. So this is mercury. This is mercury. In fact ఏంటి అంటే మెర్క్యూరీకి హాట్ గిన టచ్ అయినట్లయితే మెర్క్యూరీ ఎక్స్పాండ్ అవుతుంది. ఎక్స్పాండ్ మీన్స్ మెర్క్యూరీ అనేది రైజ్ అవుతుంది. మెర్క్యూరీ అనేది రైజ్ అవుతూ ఉంటుంది. సో దిస్ ఈజ్ మెర్క్యూరీ ఇన్ థర్మోమీటర్. దిస్ ఈజ్ రీడింగ్స్ degrees. So this is hot water, another with cold water. Take a laboratory thermometer and put it in hot water. Observe the mercury level of thermometer. Observe the mercury level of thermometer. Mercury level of thermometer is rises from. Mercury level of thermometer is rises from initial position due to heat transfer from hotter body to the colder body. Mercury level of thermometer rises from initial position due to heat transfer from hotter body to the colder body. So this is hotter body means hot water. Hotter body means hot water. Colder body means mercury in thermometer. Colder body means mercury in thermometer. Mercury in thermometer. Mercury thermometer. Once again I will repeat. Take two cups and fill one of them with hot water and another with cold water. Take a laboratory thermometer and put it in hot water. Observe the mercury level of thermometer. The mercury level of thermometer is rises from initial position due to heat transfer from hotter body to the colder body. Next, take the thermometer out of the hot water and put it in cold water. Take the thermometer out of the hot water and put it in cold water. So this is thermometer. So this is mercury position. So take the thermometer out of the hot water and put it in cold water. Observe the mercury level of thermometer. The mercury level of thermometer comes down from initial position from transfer of heat from hotter body to the colder body. Observe the mercury level of thermometer. The mercury level of thermometer comes down from initial position due to transfer of heat from hotter body to the colder body. This means hotter body means mercury in thermometer. Hotter body means mercury in thermometer. Hotter body means mercury in thermometer. Colder body means cold water. So one second, I will repeat again in this situation. So take 2 cups and fill one of them with hot water and another with cold water. Take a laboratory thermometer and put it in hot water. Observe the mercury level of thermometer. The mercury level of thermometer rises from initial position to hotter body to the colder body. At the same time, similarly, take the thermometer out of the hot water and put it in cold water. Observe the mercury level of thermometer. The mercury level of thermometer comes down from initial position due to transfer of heat from hotter body to the colder body. So hotter body means mercury in thermometer, colder body means cold water. Actually, totally this situation of heat. What is heat? Heat is a form of energy in transit that flows from a body at higher body temperature to a body at lower body temperature. Heat is a form of energy that flows from a body at higher body temperature to a body at lower body temperature. This situation. Okay. So heat is a form of energy in transit that flows from a body at higher body temperature to a body at lower body temperature until the temperature remains same for two bodies until the temperature remains same for two bodies, and it is called thermal equilibrium. So one second, I will repeat again. Heat is a form of energy that flows from a body at higher body temperature to a body at lower body temperature until the temperature remains same for two bodies, and it is called thermal equilibrium. In this above observation, so in this above cases, above cases, the steadiness of mercury column shows that temperature, thermal equilibrium is achieved. Thermal equilibrium is achieved. Once again, I will repeat again. So, in this odds, sorry, in this above cases, in this above cases, in this above cases, in this above cases, mercury column, in this above cases, mercury column, in this above cases, mercury column shows that, mercury column shows that, mercury column shows that, in this above cases, mercury column shows that thermal equilibrium, thermal equilibrium, thermal equilibrium is achieved, is achieved, is achieved. In this above cases, mercury column shows that thermal equilibrium is achieved. Actually, heat is a form of energy that flows from a body at higher body temperature to a body at lower body temperature until the temperature remains same for two bodies, until the same temperature remains same for two bodies, and it is called thermal equilibrium. In this above cases, mercury column shows that thermal equilibrium is achieved. So next one, so next one, so next one, so next one, that's record, that's a record of mercury column, that's records of, that record of mercury column, mercury column gives the temperature at equilibrium, temperature at equilibrium, temperature at equilibrium. So final position, the record of mercury column gives the temperature at equilibrium. Once again, that record of mercury column gives the temperature at equilibrium, equilibrium. So the temperature of a measure of thermal equilibrium, temperature is a measure of thermal equilibrium, temperature is a measure of thermal equilibrium. So once again, I will repeat again this situation totally. So first of all, explain thermal equilibrium is an activity. Take 2 cups and fill with one of them with hot water and another with cold water. Take the laboratory thermometer and put it in hot water and another with cold water. So heat is a form of energy that flows from a body at higher body temperature to a body at lower body temperature. So until the temperature remains same for two bodies, and it is called thermal equilibrium. In this above cases, mercury column shows that thermal equilibrium is achieved. So final point is the record of mercury column gives the temperature at equilibrium. So final point is the record of mercury column gives the temperature at equilibrium. So mercury is a temperature is a measure of thermal equilibrium. Temperature is a measure of thermal equilibrium. So temperature is a measure of, temperature is a measure of thermal equilibrium. 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 The record of mercury column gives the temperature at equilibrium, and the temperature is a mercury of thermal equilibrium. So this is called as thermal equilibrium. So ఎప్పుడైనా సరే థర్మోమీటర్ లో ఉండేటువంటి మెర్క్యూరీ అనేది స్టడీగా ఉన్నట్లయితే ఆ మెర్క్యూరీకి వాటర్కి మధ్య హీట్ ట్రాన్స్ఫర్ అనేది ఆగిపోతూ ఉంటుంది. ఇలా హీట్ ట్రాన్స్ఫర్ ఆగిపోయిందంటే అక్కడ థర్మల్ ఈక్విలిబ్రియం అనేది ఫామ్ అవుతుంది. ఈ థర్మల్ ఈక్విలిబ్రియం ఫామ్ అయిన వెంటనే మనకు థర్మోమీటర్ రీడింగ్ అనేది మనకి ఏం తెలియజేస్తూ ఉంటుందంటే టెంపరేచర్ ని తెలియజేస్తూ ఉంటుంది. అందుకే మనం ఏం చెప్తున్నాం, టెంపరేచర్ ఈజ్ ఏ మెజర్ ఆఫ్ థర్మల్ ఈక్విలిబ్రియం. టెంపరేచర్ ను థర్మల్ ఈక్విలిబ్రియం యొక్క మెజర్ అని చెప్పేసి పిలుస్తూ ఉంటాము. టెంపరేచర్ ఈజ్ ఏ మెజర్ ఆఫ్ థర్మల్ ఈక్విలిబ్రియం. And next one, units of heat. Units of heat, SI units and CGS units. SI units joules, SI units joules, CGS units calorie, CGS units calorie. Units of heat, SI units joule J తో డినోట్ చేస్తారు. CGS means CGS units వచ్చేసి calorie. So next one, units of temperature. Units of temperature, SI units and CGS units. SI units kelvins K తో డినోట్ చేస్తారు. CGS units degree centigrade and degree Fahrenheit. Units of temperature, SI units kelvins, CGS units degree centigrade and degree Fahrenheit. So what is calorie? What is calorie? The definition of calorie: the amount of heat required to raise the temperature of 1 gram of water by 1 degree centigrade is called as calorie. So the amount of heat required, the amount of heat required to temperature of 1 gram of water by 1 degree centigrade is called calorie. Is called calorie. The amount of heat required to temperature of 1 gram of water by 1 degree centigrade is called calorie. So the amount of heat required to temperature of 1 gram of water by 1 degree centigrade is called calorie. So the conversion of calorie into joules, joules into calorie. So 1 calorie is equal to 4.186 joules. So 1 calorie is equal to 4.186 joules. So 1 calorie is equal to 4.186 joules. And the next one, units of temperature. Actually the simple definition of temperature: the degree of hotness or coldness is called as temperature. SI units kelvins, CGS units degree centigrade. So degree centigrade is converted into Kelvin, kelvins is converted into degree centigrade. How is possible? So actually 0 degree centigrade is 273 Kelvin. So degree centigrade is converted into kelvins. Kelvins is converted into degree centigrade. So 0 degree centigrade is 273 Kelvin. How is possible? So this simple. 0 degree centigrade is equal to 273 Kelvin. So temperature in Kelvin is equal to 273 plus temperature of degree Celsius. So temperature in Kelvin scale, temperature in Kelvin is equal to 273 plus temperature in degree Celsius, temperature in degree Celsius, temperature in degree Celsius. Temperature in Kelvin scale is equal to 273 plus temperature in degree Celsius. So how do you convert the kelvins to Celsius? Degree Celsius is converted into Kelvin scale. How is possible? So, suppose example 0 degree. So, temperature in Kelvin K is equal to 273, 273 plus temperature in degree Celsius. So, 273 plus 6. So, temperature in Kelvin scale is equal to 273. Degree centigrade is converted to Kelvins because of answer 273 Kelvin. So, temperature in degree Celsius 6. So, K is equal to 273. This 0 degree centigrade plus 0. So, K is equal to 273. So, because 0 degree centigrade is 273 K Kelvin. So this is final answer. So 0 degree centigrade is equal to 273 Kelvin. So temperature in Kelvin K is equal to 273 plus temperature in degree Celsius C. So degree Celsius is mean 0 degree Celsius. Final K 273. So K is equal to 273. So K is equal to 273 plus C means 0 degree centigrade. So K is equal to 273. So final ga 0 degree centigrade is converted to Kelvin. The final answer is 273 K Kelvin. So because. So next one. Next one. Convert 20 degrees Celsius into Kelvin scale. Convert 20 degrees Celsius into Kelvin scale. Actually the formula K is equal to 273 plus 6. K means temperature in kelvins. 273, 0 degree centigrade is converted into kelvins because of answer 273. C means temperature in degree Celsius. So K is equal to 273 plus C means 20 degree centigrade. So 20. K is equal to 293. K is equal to 293. So final answer 20 degrees centigrade is equal to 293 Kelvin. 293 Kelvin. So in this problem, solve the another method. So 20 degrees Celsius. C minus 0 by 100 minus 0 is equal to F minus 32 by 212 minus 32 and K minus 273 by 373 minus 273. So this one, there is no Fahrenheit. So because this formula C minus 0 by 100 minus 0 is equal K minus 273 by 373 minus 273 100. So C minus 0 by 100 minus 0 is equal K minus 273 by 100. So 0 0 cancel. C by 100 is equal K minus 273 by 100. 100 cancel. So C is equal to K minus 273. So మనకు కావాల్సిన ఆన్సర్ K కాబట్టి K side K is equal to C plus 273. K is equal to C means 20 degrees. 20 plus 273. 20 plus 273. 20 plus 273. So K equal to 293. So 20 degrees Celsius is converted into Kelvin scale. The final answer is 293 Kelvin. 293 Kelvin. So temperature is measured on Kelvin scale is called absolute temperature. Temperature is measured on Kelvin scale is called absolute temperature. Case 2 and case 1. This is another method. This is another method. One of the and another method. This simple formula. This is the simple also simple formula. So convert 20 degrees Celsius into Kelvin scale. Temperature in Kelvin is equal 0 degrees centigrade is converted into Kelvin. The final answer is 273 plus C. C means temperature in degrees Celsius. K is equal to 273. What is C20? Right. So C means 20 degrees centigrade. So K is equal to 293. So 20 degrees Celsius is equal to 293 Kelvin. And next one, C minus 0 by 100 minus 0 is equal F minus 32 by 212 minus 32 is equal K minus 273 by 373 minus 273. So C minus 0 by 100 minus 0. So now 0 0 cancel. 100 cancel. C is equal to K minus 273. So K మనకు కావాల్సింది K కాబట్టి K యువతలకు వస్తే K is equal to C plus 273. So K is equal to C means 20 plus 273. So K is equal to 293. So 20 degrees Celsius is converted into Kelvin scale. The final answer is 293 kelvins. 293 kelvins. So because why done? Temperature is measured on Kelvin scale is called absolute temperature. Temperature is measured on Kelvin scale is called absolute temperature. So try to another question. Convert. Try to another question. Convert 10 degree centigrade. Convert 10 degree centigrade into Kelvin scale. So K is equal to 273 plus 6. So K equal to 273 plus 10. So K is equal to 273 plus 10, 283. So the final answer is 10 degrees centigrade is equal to 283 kelvins. So the simple note, temperature is measured on Kelvin scale is called temperature is measured on Kelvin scale is called absolute temperature. So temperature is measured on Kelvin scale is called absolute temperature. So next to terminology, kinetic energy and temperature. Kinetic energy and temperature. Kinetic energy and temperature. So next terminology, kinetic energy and temperature. So what is kinetic energy? The simple definition of kinetic energy: if any body which is in motion will show that the kinetic energy. That means the movement of a body. So once again I will repeat, what is kinetic energy? If any body which is in motion will show that the kinetic energy, the movement of a body. That means the movement of a body. And next temperature. So the degree of hotness or coldness is called temperature. The degree of hotness or coldness of a body is called temperature. So what is the relation between kinetic energy and temperature? So kinetic energy is directly proportional to the temperature. Kinetic energy is directly proportional to the temperature. That is the relation between kinetic energy is directly proportional to the temperature. So that means kinetic energy increasing, temperature will also increasing. Temperature will also increases. So kinetic energy increasing, temperature will also increasing. That means kinetic energy increasing, temperature will also increasing. So what is the relation between kinetic energy and temperature? Kinetic energy is directly proportional. The symbol name is directly proportional to. Kinetic energy is directly proportional to the temperature. That means kinetic energy increasing, temperature will also increases. So how to prove the relation between kinetic energy and temperature with an activity? So first take two bowls, and one with cold water and another with hot water. So take two bowls, so fill one of them with hot water and another with cold water. So this is a hot water, this is cold water. So gently sprinkle food color on the surface of water in both bowls. Gently sprinkle food color on the surface of the water in both bowls. So this is sprinkle food color. This is sprinkle food color. So gently sprinkle food color of the surface of the water in both bowls. We will observe the jiggling of small particles of food color in hot water is more when compared to the cold water. So we will observe the jiggling of small particles of food color in hot water is more when compared to the cold water. That means kinetic energy is high, kinetic energy is low, temperature is high, temperature is low. So once again I will repeat again. The jiggling of small particles of food color in hot water is more when compared to the jiggling of cold water. So actually kinetic energy is depend on the speed of motion of particles. So kinetic energy is depend on the speed of motion of the particles. So average kinetic energy of hot water is greater than that of cold water. So average kinetic energy of hot water is greater than that of average kinetic energy of cold water. So next one, this important point. Temperature of a body. So temperature of a body is an is an is an indicator of temperature of a body is an indicator of average kinetic energy of molecules of that body So temperature of a body is an indicator of average kinetic energy of molecules of that body. So this means ఒక బాడీ యొక్క టెంపరేచర్ అనేది ఆ బాడీలో ఉండేటువంటి యావరేజ్ కైనెటిక్ ఎనర్జీ ఆఫ్ మాలిక్యూల్స్ గురించి మాలిక్యూల్స్ కి ఇండికేటర్ గా పనిచేస్తూ ఉంటుంది. సో వన్స్ అగైన్ ఐ విల్ రిపీట్ అగైన్, టెంపరేచర్ ఆఫ్ ఏ బాడీ ఈజ్ ఎన్ ఇండికేటర్ ఆఫ్ యావరేజ్ కైనెటిక్ ఎనర్జీ ఆఫ్ మాలిక్యూల్స్ ఆఫ్ దట్ బాడీ. ఒక బాడీ యొక్క టెంపరేచర్ అనేది అదే బాడీలో ఉండేటువంటి యావరేజ్ కైనెటిక్ ఎనర్జీ మాలిక్యూల్స్ కి ఇండికేటర్ గా పనిచేస్తుంది. సో నెక్స్ట్ వన్, దిస్ మీన్స్ this means kinetic energy high. This means kinetic energy high, temperature high, and next kinetic energy low, temperature low. So and last one, so important point, the average kinetic energy of the molecules, the average kinetic energy of molecules is an indicator of, so and the next one, average kinetic energy of molecules, average kinetic energy of molecules, average kinetic energy of molecules is directly proportional to the is directly proportional to the absolute temperature. Absolute temperature. Average kinetic energy of molecules is directly proportional to the absolute temperature. So what is kinetic energy? First of all, if any body which is in motion will show that the kinetic energy, that means the body, the movement of a body, and temperature, the degree of hotness or coldness is a body is called temperature. So what is the relation between kinetic energy and temperature? Kinetic energy increasing, temperature will also increases. So kinetic energy is directly proportional to the temperature. That means kinetic energy increasing, temperature will also increasing. So take two bowls, one with cold water and another with hot water. Gently sprinkle food color on the surface of the water in both bowls. So the jiggling of small particles, the jiggling in the small particles of food color in hot water is more when compared to the cold water. So that means kinetic energy is depend on speed of motion of particles. Temperature of a body is an indicator of average kinetic energy of molecules of that body. ఒక బాడీ టెంపరేచర్ అనేది ఆ బాడీలో ఉండేటువంటి యావరేజ్ కైనెటిక్ ఎనర్జీ ఆఫ్ మాలిక్యూల్స్ కి ఇండికేటర్ గా పనిచేస్తూ ఉంటుంది. సో ఫైనల్ పాయింట్, యావరేజ్ కైనెటిక్ ఎనర్జీ ఆఫ్ మాలిక్యూల్స్ ఈజ్ డైరెక్ట్లీ ప్రొపోర్షనల్ టు ది టెంపరేచర్, అబ్సల్యూట్ టెంపరేచర్. సో దట్స్ రైట్. So the relation between heat and temperature and thermal equilibrium and kinetic energy. So this one, actually temperature is a determine the direction of heat flows. So heat is a form of energy. The heat flows from hotter body to the colder body. So temperature is a determine the direction of heat flows. So take this one of the activity, try to activity. So take water in a container. Take water in a container and heat it to 60 degree centigrade. So take water in a container and heat it to 60 degree centigrade. So take a transparent cylindrical glass jar and fill half of with the hot water and pour some coconut oil over the surface of water. So take a cylindrical transparent glass jar and fill half of with the hot water and pour some coconut oil over the surface of water. Next, put a lid with the two holes on the top of the glass jar and insert two thermometers. The bulb of thermometer, one has inside coconut oil and another is in hot water. So the bulb of thermometer, one has inside hot water and another in coconut oil. So now we can observe this activity. So now we can observe the mercury law of readings. So the reading of thermometers. So the reading of hot water thermometer decreases continuously, and while the reading of coconut oil thermometer continuously increasing. So we can observe this diagram. So the reading of hot water thermometer continuously decreasing, and while the reading of coconut oil thermometer continuously increasing. This means the hot water losses energy. So the water losses energy and oil gain energy. So this means the water losses energy and oil gain energy. This means the temperature difference between oil and water. The temperature difference between oil and water. So the average kinetic energy of the molecule of hot water decreases, and the kinetic energy of the molecule oil increases. So the average kinetic energy of the molecule of hot water decreases, and the average kinetic energy of the molecules oil increases. So this means temperature of water decreases. Temperature of water decreases, whereas temperature of oil increases. Actually this means heat flow from this means heat flow from water to oil. So temperature increasing, this means coconut oil and kinetic energy increases. Temperatures increases, kinetic energy increases. So water, this means temperatures decreases, kinetic energy decreases. Temperature increases, kinetic energy decreases. So this means coconut oil. So this means temperatures increases, kinetic energy increases. So temperature decreases, kinetic energy decreases. So and last one, temperature is determined. So last point, temperature is determined the direction of temperature is determined the direction of heat flows. So this means temperature is determined the direction of heat flows. Is very important point. Very important points. Totally, this activity means temperature is determined the direction of heat flows. So heat is a form of energy. Heat is a flows from hotter body to the colder body. So